So in this question, electrical energy produced by power station is transmitted over a long distance at very high volts. Explain why very high voltage is used. What is the reason of using a high voltage for our power transmission or to transfer the power from one place to another? So basically when we use high voltage, the step up transformer increases the voltage and it reduces the current. So if there's a low current, it means less energy will be wasted or less heat energy will be produced. And if we are using a low current, so we can use like cheaper transmission cables, or we can use cable with a less resistance, or cheaper pylon can also be used. That's the advantage of using the step up transformer for power transmission. Step up transformer is used. So when we use a step up transformer, what they will do, it increases the voltage will increase the voltage and it will reduce the current. And because the current reduced, so small current through a transmission cable means less amount of heat energy. So less energy is wasted in the form of heat, because current is having a heating effect. More current means greater heating effect. Small current means less heating effect. And if less heating effect is there, so we can use cheaper cables can be used for transmission. So for this purpose we can use cheaper cables for transmission. So for power transmission, always we use a step up transformer. Step up transformer increases the voltage, so it reduces the current. As it reduces the current, so small current means less heating effect will be there. As a result, less heating effect, smaller amount of energy will be wasted. And we can now for transmission we can use cheaper cables or cheaper pylons for the transmission. Figure 10.1 represent a transformer. So by looking at a transformer, you should be able to identify which transformer is this. As you can see, P means here primary and S means secondary. So primary is having more turns. The input or the primary is having more turns. The output is having few turns, less turns. So which transformer is this? If the input, the primary is having more turns and the secondary is having less turn, so this transformer is a step down. Even without turn, you can also identify from the voltage where the supply is connected, that's 120, and it is just converting into 9 volts, so it is reducing the voltage. In the question, a primary coil has 4000 turns. So number of turns of primary, or NP, equals 4000. The input voltage, so input voltage is called VP, which is 120. The secondary voltage we don't know. Secondary voltage is 9 and number of the secondary we don't know, the turns. So we'll use a formula Vs, voltage of the secondary divided by voltage of the primary, equals number of turns of secondary divided by number of turns of primary. So Vs over Vp equal Ns over Np. Vs is the voltage of secondary, which is 9. Np is the number of the turns of primary, which is 120. Vp is the voltage of the primary, which is 120. Ns is the number of turns of secondary, and Np is the number of turns of uh, primary, which is 4000. So we simplify, 4000 will be multiplied, so it will be 9 multiplied by 4000 divided by 120. That will give us Ns. So when we multiply, we solve, we'll get the number of turns of secondary, which will come out as 300 turns. Suggest a suitable material for the core. This core of a transformer, it is made up of iron. If they ask suitable material for the coil, the wire, then it will be copper. So which is a suitable material here? That is iron. Another question, there is a DC supply, direct current supply. Figure shows a DC supply. Transformer cannot work with DC. It can only work with AC because DC does not produce a continuous change in magnetic field. It produces a constant magnetic field. Figure shows a DC supply is connected to the input of a transformer. When the switch is closed, the moment we close the switch, when the switch is first closed, the needle of the galvanometer briefly deflect and then return. Explain why. Because what happened when we close the switch, that moment only the current changes. And because the current changes, due to change in the current, there's a change in magnetic field. And due to change in magnetic field, there will be a EMF. And due to that change in EMF, the needle of the galvanometer, if it was zero centered, so it will deflect. But because it's a DC supply, so DC supply, the current will become constant. Once the current is constant, there is no change in magnetic field, so there is no induced EMF. So the moment we close the switch, that time only the current changes. So it's of 3 marks. So what is the reason for that? When the switch is closed, there is a current changes for a very short time, which induce EMF in the secondary, cause a needle to deflect. But when the DC current become constant, there is no change in magnetic field. That's why the galvanometer does not show any deflection. So answer here, when the switch is closed, there is change in magnetic field for a very short time, which produce variable magnetic field for a short time, and induce EMF or voltage or current in secondary coil. So the needle of galvanometer is used to detect the very small change in current, deflects. Then the current became constant. So there is no change in the magnetic field. No induced EMF. So the needle returned to 0. this is the complete answer, that why initially there is, because the moment we close the switch, very short time, there is a change in current, and that change in current induces EMF. But because that produces changing magnetic field which induces EMF. But because it's a DC supply, as I mentioned, transformer cannot work with DC because the DC does not produce changing magnetic field. AC produce changing magnetic field. That's why transformer can only work with AC, cannot work with DC. The next question, explain why the voltage of a supply to a primary coil of a transformer must be alternating. So this is a similar question, that why it cannot be DC, why it should be AC always. Because when it's an AC input, it produces changing magnetic field, and changing magnetic field can induce. So AC input can produce variable magnetic field which can induce EMF in secondary coil. So this question they can ask, why transformer cannot work with DC. So what will be your answer? You will mention, because direct current does not produce it produces a constant magnetic field, and constant magnetic field cannot induce EMF. Or the question can be, why alternating current is used for the transformer, because alternating current produce variable magnetic field, and that variable magnetic field, can induce EMF. So another question, figure 10.1 shows a transformer. There's a 240 volts main supply is there, 800 turns. So where we connect a supply, that's called a primary. So this is a primary coil, and here this one is a secondary. Voltage of the primary, you can see secondary is having less turns. So this clearly shows this is a step down transformer. Like it will reduce the voltage. In the question, we want to find the number of the turns So we want to find the number of turns of the secondary. So we will use a formula, Vs over Vp equals Ns over Np. So voltage of the secondary, that is 6. Voltage of the primary, that is 240. Number of the turns of the secondary, we don't know, and number of the turns of the primary, they mention it is 8,000. So this is 8,000. So we simplify this, 6 multiplied by 8,000 divided by 240. That will give us the number of the turns of secondary. So this will, because it's a step down transformer, the number of turns of secondary should be less than primary, so it will come out as 2000. The next, the current in the lamp is 2 ampere. The transformer operates with 100% efficiency. What is the input current? If the transformer is 100% efficient, voltage of the primary, current of the primary is equals to voltage of secondary, current of secondary. Because the power input and power output will be same. So Vp Ip is equals to Vs Is. The voltage of the primary voltage, that is 240. Primary current we don't know, the input current or primary current. Voltage of the secondary, it is converting the voltage to 6, multiplied by number of turns of multiplied by current in the primary, the current in the secondary, sorry. The formula is Vp Ip is equals to Vs Is. So current in the secondary, because lamp is connected to a secondary, so current in the secondary is 2. So this will be 2. When we simplify, IP is equals to 6 multiplied by 2, that is 12 divided by 240. So 12 divided by 240, that's equal to 0.05 ampere. So 0.05 ampere is a current. Then the primary circuit contained 2 ampere fuse. So there is a 2 ampere fuse. Calculate the maximum number of the lamps identically to the lamp in A1 that can be connected in parallel without the fuse below. Like how many lamps can be connected so that the fuse does not blow? Fuse maximum can allow 2, and each lamp, for when one lamp is connected, it is 0.05. So how we'll know the total number of the lamps? The total current divided by current in each lamp. The primary current for each lamp will get the total number of the lamps. So the number of the lamps is equals to total current divided by current in each lamp, or current for one lamp. So total current with the fuse can apply, that is 2. And each lamp, when one lamp is connected, the current is needed is 0.05. So 2 divided by 0.05, it will give us the 40. So we can connect 40 lamps before the fuse will below, because like one lamp is 0.05, then 2 lamps will be 0.1, 3 lamps will be 0.15, 4 lamps will be 0.2, and so on until we connect the 40 lamps. When we connect the 40 lamps, the current will be 2. If we connect the 41st, like 41 lamps, then the current will be more than 2 and the fuse will blow. So another question: a transformer consists of 2 coils of a wire which wound on a metal core. Name a material from which the core is made. So core is made up of iron. If they ask coil is made up of, then it will be copper. Then the primary coil of a transformer is connected to the output voltage AC generator. Explain why there is a voltage between the 2 terminals of a secondary coil. So basically you have to explain the working of a transformer here. So why the transformer is working? So AC input produce variable magnetic field, and due to this variable magnetic field, what will happen? It magnetizes the iron, and there is a change in magnetic field of iron. Induce EMF in secondary coil. So this is the working of a transformer. Then there are 560 turns in the primary. So we know the number of turns of primary, NP is known. Number of turns of secondary, NS is known. Voltage of the secondary, VS is known. We need voltage of the, because voltage of the supply, input voltage, or we can say VP. So the formula is VS over VP equal NS over NP. We substitute the value. Voltage of the secondary is 78. Voltage of the primary we don't know. Number of the turns of secondary are 910, and number of turns of primary 560. We cross multiply. So 78 multiplied by 560 is equals to 910 multiplied by VP. We need VP, so 910 will go there in division. 78 into 560 divided by 910. That will give us voltage of the primary. So when we substitute these values, this will give us a voltage of the primary, which will come out as 48 volts. And it is obvious because the secondary is having more turns, so it means it will be a step up transformer. Output voltage is higher, so if output is 78, the input should be less than 78 according to the turn ratio. Then transformer are used to increase the voltage in electrical transmission. Explain why power losses in the cable are lower when it is transmitted at high voltage. So the same answer, what happens? Step up transformer increase the voltage and reduce the current, which minimize the power losses in the form of, or energy loss in the form of heat. So whenever power transmission is done, the power is always transmitted at high voltage and low current by using a step up transformer. So high voltage reduces the current, less current means less heating effect, or most of the energy will be transferred. Another question related to transformer. An AC supply is connected across a primary coil and a 12-volt lamp is connected across a secondary. The lamp glow with a normal brightness. State the name of a device shown. What we call this device? We call this as a transformer. Then explain why there is a current in the lamp. Basically, you have to explain the working of a transformer. It's a 4 marks. So why there is a current in lamp? AC input produces variable magnetic field. And it magnetizes the iron core. And change in magnetic field of the core induce EMF in the secondary. And as a result, what happened? The current produced when the circuit is closed. Like when the circuit closed means when the components are connected, the current start to move. Then the coil connected to the lamp has 450 turns. The EMF of the AC supply is 240. Calculate the number of turns of the coil connected to AC supply. AC supply means input, like NP we need. And it is converting, the coil is the lamp, how much the lamp is using? 12 volts. So that is, the lamp is using 12 volt, lamp is connected here. That is using 12 volt. And the input is 240. So lamp consume 12 volts. Input is 240, 240. Number of turns of secondary are given in the question, that they mention that 450 are there. That is a secondary. So number of turns of secondary are 450. We need number of turns of primary. So we use a formula Vs over Vp equal Ns over Np. So voltage of secondary is 12. Voltage of the primary is 240. Number of turns of secondary, That is 450 divided by number of the turns of primary NP. So NP is equals to 450 multiplied by 12 divided by 240. This will give us the number of turns of the primary coil. So when we simplify this to get the final answer, the number of turns of the primary, this will give us 450 into 12 divided by 240. So Bs over Vp equal Ns over Np. Sorry, it will be 200 because we need Np. I should cross multiply. So this 240 will go there in multiplication. So 450 multiplied by 240 and that is divided by 12. This will give us number of turns of primary. That will come out about 9,000 turns. If a 240 volt DC supply is used, the transformer never work with DC, it only work with AC. So transformer will not work. If the transformer will not work, the lamp does not glow. The lamp will not, because if there's a DC supply, there's no change in magnetic field. And if there's no change in magnetic field, there is no induced EMF. And when there's no induced EMF, there is no current produced by the transformer. So these are some questions related to the transformer. So remaining question I want you to solve by yourself.